In section 11.1 on sequences and series, we're going to start out by first talking about what is a sequence. A sequence is just a list of things. We usually think of sequences as numbers because we're in a math class. Good example of a sequence would be this first one here. It starts out with the first term, 3, the second term, 5, then 7, then 9. So we're looking at a list of odd numbers, in which case at the end we have 3 dots indicating that the list is going to go on forever. Each term that we have, each piece of our sequence is called a term, or an element, or a member, whichever word you want to use, they all mean the same thing. Sequences can end. If they do end, they're called finite. If they don't, they are called infinite sequences. Usually they do follow a pattern of some sort. A sequence is just a set of numbers. That's why we use the braces. So these are our sets. That's why we use the little braces. And you can use those on infinite or finite sets or sequences. The terms are generally in order. Let's see. The terms can have a repeating value. So, for example, the sequence might be 0, 1, 0, 1, 0, 1, repeating on forever. But then if we actually look at the set would just contain your possibilities, which are just 0 and 1. You can define your sequences using rules, which gives you a way to find each term in your sequence. A good example would be this first one, where we have a sub n equals n plus 2. What it tells you is how to find the first term, the second term, the third term. So for instance, if you wanted to find the first term, we would plug in n equals 1. That would be the numbered term as 1. And what you would get is that a1 would be the name of the term. And you'd be plugging in 1 for all the n's. So it'd be 1 plus 2 equals 3. What this means is that your first term is just the number 3. And then you could do that for the second term. So you'd find a sub 2, which is equal to 2 plus 2, which is 4. So the second term would be 4, and you can keep on going to find any term that you want. So, continuing along, they can give you an equation like this, a sub n, for this first example, a sub n equals 6n minus 3. And we can find the first 5 terms of the sequence by looking at n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5. So we'd plug in 1, 2, 3, 4, and 5 for our n. Plugging in 1, 2, 3, 4, and 5 for our n's, we get 6 times whatever number it is, and then minus 3. So on the first one, we get 3, because we get 6 minus 3, which is 3. The next one, we get 12 minus 3, which is 9. The third one, we get 6 times 3, which is 18, minus 3 is 15. Next one is 6 times 4 is 24, minus 3 is 21. And the last one here is 6 times 5 is 30, minus 3 is 27. So those are our first 5 terms of our sequence. They are, let's see, what did we find? 3, 9, 15, 21, and 27. In problem B, we have a sub n equals n minus 7 over n minus 6. Again, they only want the first 5 terms, so that means we're going to plug in 1, 2, 3, 4, and 5 for our n here. So when we plug in our 1, 2, 3, 4, and 5 for our n's, we just need to make sure that we do an order of operation by simplifying the numerators and denominators before we actually do the division. So on this first one, the 1 minus 7 gets us negative 6, and the 1 minus 6 gets us negative 5. Well, negative divided by a negative does get us a positive, so we get a positive 6/5. On the next one, on on a sub 2, we get 2 minus 7 and 2 minus 6. Well, that gets us negative 5 and negative 4 on the top and bottom. So then, again, we have a negative divided by a negative, which will again turn into a positive 5/4. The next one, we've got a 3 minus 7 and a 3 minus 6, which will get us a negative 4 and a negative 3, which will turn into a positive 4/3. And fourth term, we get a 4 minus 7 and a 4 minus 6, which will get us a negative 3 and a negative 2, which will turn again to a positive, which will leave us with a positive 3/2. On the last one, on 5, we end up with a negative 2 over a negative 1, which will again give us a positive 2. So our solutions are as follows. The first one, a sub 1, was 6/5. The second one was 5/4. And the third one was 4/3. And then 3/2. And the last one was a positive 2. All of these were positives because we had 2 negatives divided. And so that's our list of the first 5 terms.